Hello everyone, hope you are happy and healthy. Let us begin today's session. As we are learning chemical properties of metals, today we will learn what happens when metals react with acids. So, for learning this, we need to learn an activity. For activity, we will need samples of metals. We will make use of the samples which we have taken for other activities. We will take aluminium, copper, iron, lead, magnesium, zinc. Here, kindly take a note that we will not use sodium and potassium because sodium and potassium react with water vigorously. So, if it reacts with water so immediately, suddenly, we will not make use of potassium and sodium for reacting with acids. All other samples we will take and we will need a test tube to put this dilute hydrochloric acid into it. Then we will take the samples separately in test tubes and we will observe the change. Here you can make use of a beaker instead of a test tube. We will observe that metal when reacted with dilute acid it gives salt and hydrogen. This we have already studied in chapter 2. So, the common equation, general equation will be metal plus dilute acid gives salt plus hydrogen. This is the common equation. From this equation, you can make examples. Let us learn this by taking examples. First, when iron is reacted with dilute hydrochloric acid, it gives iron chloride. Also, the hydrogen gas is evolved. Now you will be thinking how this hydrogen gas will be evolved. So, when you put a small piece of this metal in a test tube, you will see bubbles are generated in the test tube, and that shows that it is a hydrogen gas. So when you see bubbles in the test tube in the reaction of metal and dilute acid, it is the evolution of hydrogen gas. So for this example, you need to take a small piece of iron which you will pick with a pair of tongs and you will put it into a test tube which is filled with dilute hydrochloric acid and it gives salt and the name of salt is iron chloride. Also, hydrogen gas is evolved. So the chemical reaction of this will be Fe plus 2HCl gives FeCl2, that is iron chloride, plus H2. If we take example of magnesium and we'll take a piece of magnesium and if we put it into a test tube which is filled with dilute hydrochloric acid, it gives magnesium chloride and hydrogen gas is evolved. How will you see that hydrogen gas is evolved? You will be able to see the bubbles formed in a test tube. So the chemical reaction for this is Mg plus 2HCl that gives MgCl2 which is magnesium chloride plus H2 hydrogen. If we take example of aluminium, then aluminium reacts with dilute hydrochloric acid and it gives aluminium chloride. Here, what will be the equation? It will be 2Al plus 6 HCl. That gives 2AlCl3. AlCl3 is aluminum chloride plus 3H2. If we take example of zinc, then when a small piece of zinc is taken and it is kept in a test tube filled with dilute hydrochloric acid, it forms zinc chloride and hydrogen gas is evolved. What will be the equation for this? It is Zn plus 2HCl, which gives ZnCl2 plus H2. ZnCl2 is zinc chloride. So these are some of the examples for reaction between metal and acids. So here we have taken dilute hydrochloric acid, and with these samples we have seen how does it react and what does it form. Also it forms hydrogen gas. So you need to remember a common general equation so that you can write examples. General equation is metal plus dilute acid gives salt and hydrogen. Till now we talked about dilute hydrochloric acid. But if we take nitric acid, HNO3, if we take nitric acid, then what happens? So when a metal reacts with nitric acid, we will see that hydrogen gas is not evolved. This is the difference. When we have taken dilute hydrochloric acid, that time hydrogen was evolved. But when we take nitric acid, then when a metal reacts with it, hydrogen gas is not evolved. Why is it so? Because nitric acid HNO3 is a strong oxidizing agent. What is oxidizing agent? We all know that the substance which does oxidation is called oxidizing agent. So nitric acid is a strong oxidizing agent. What does it do? It oxidizes the H2 produced to water. Now we all know what is oxidation. When oxygen is added in the reaction, then it is called oxidation. So when a reaction between a metal and nitric acid happens, hydrogen gas will not be evolved. Why? Because this nitric acid will make this hydrogen into water. There is a hydrogen. If you add oxygen to it, it becomes water, right? H2O. So this nitric acid oxidizes H2 to produce water, and itself gets reduced to any of the nitrogen oxides like N2O, NO or NO2. But magnesium and manganese are the metals which react with very dilute nitric acid to evolve H2 gas. So these two are exceptions. Magnesium and manganese, they react with very dilute nitric acid and which evolves hydrogen gas. When magnesium reacts with dilute hydrochloric acid and it forms magnesium chloride, the rate of formation of bubbles was the fastest in this reaction. The evolution of hydrogen gas. When we see bubbles generated in the test tube, it is hydrogen gas. So for this case in magnesium, we will see that the rate of formation of bubbles will be very fast. The reaction was also the most exothermic, which means it releases heat. So the reactivity will be in order: magnesium, aluminium, zinc and iron. What is reactivity? It is the ability of metals to react with other substances. So, magnesium has highest reactivity, then aluminium, then zinc, and then iron. So, this is the order of reactivity. It is in decreasing order. If you take a small piece of copper and if you keep it in dilute hydrochloric acid, you will observe that no bubbles are formed. This shows that copper does not react with dilute hydrochloric acid. Keep it in mind, copper does not react with dilute hydrochloric acid. That is why no bubbles are formed. So this is all about reactions of metals with acids.